In this problem, we're told a figure skater can increase her spin rotation rate from an initial rate of 1 revolution every 1.5 seconds to a final rate of 2.5 revolutions per second. If her initial moment of inertia was 4.6 kilogram meters squared, what is her final moment of inertia? So in order to solve this problem, you need to know what the law of conservation of angular momentum is, which basically just tells us that the initial angular momentum is equal to the final angular momentum. And we know angular momentum is equal to rotational inertia, or the inertia multiplied by the angular velocity, right? So L equals I omega. So basically what this tells us is that I sub 1, or the initial inertia, right, times the initial angular velocity, I'm just going to call it I sub 1 and omega 1, is equal to the final inertia multiplied by the final angular velocity, right? So we can use this formula in order to solve. So what we're going to want to do is go ahead and write down our given. So what do we know? So basically what we're going to do is they tell us all of these different variables, and we're going to be able to solve for what they want us to find. So they tell us that it's going to start at a rotation rate, initial rate of 1 revolution every 1.5 seconds. So when I put the 1 here, that just means initial, and then the 2 is going to be final, right? So I could write initial and final. I just chose 1 and 2 though. So essentially, angular velocity 1 is going to be 1 revolution every 1.5 seconds, right? Because they tell us it's going to start at this, and then W sub 2, or the final angular velocity, is going to be 2.5 revolutions per second, right? So we go from this to this, and then they tell us the initial moment of inertia, or I sub 1 in this case, is going to be 4.6 kilogram meters squared. So 4.6 kilogram meters squared. And then what we're trying to do is find the final, which is the 2, right? 2 means final, so we're trying to find the final inertia. So what we can do is just go ahead and solve, right? Because we have all these, and we can just solve for I sub 2. So if we divide both sides by omega 2, we can solve for I sub 2, right? So I sub 2 is going to be equal to I sub 1, and then multiplied by omega 1 divided by omega 2. So all we got to do is just plug in our units, or plug in our variables, and we can solve. So I sub 1 is 4.6 multiplied by omega sub 1, right? So angular velocity 1, which is 1 divided by 1.5, and then divide that by 2.5, right? Because omega 2 is 2.5. So if you go ahead and do this, 4.6 times 1 divided by 1.5 divided by 2.5, you're going to get that I sub 2 is equal to 1.2266 and so on. So I'm just going to go ahead and round it to 1.2. And so keep in mind the units for this, it's going to be kilogram meter squared. So kilogram meter squared. But yeah, right? Because this is going to be essentially the inertia. And then these units cancel out because they're the same. So 1.2 kilogram meters squared. But yeah, so essentially this right here is going to be your answer. 1.2 kilogram meters squared. But yeah, if you want to use the more exact version, just use this one, whatever your teacher wants you to do. But yeah, so this is going to be your answer, and hopefully you found this useful.